In this lesson, we'll talk about the inverse trigonometric functions and how to take integrals with these. These three forms are the ones that you want to recognize when you see them. Definitely be able to recognize these. I've never taught a class where I expected someone to memorize these because they are hard to keep in your head straight. However, you want to be able to know that when I see this form show up in an integral, I'm looking at an inverse trig function. Sometimes they're hard to spot. This is the special type of u-substitution that I've mentioned previously, where you choose your u so that your du holds. We'll see some examples of this as we go. For our first example, we see that this is in the form of the inverse sine function. A here is 4, and so we can get our answer immediately. This is the inverse sine of x over 4 plus c. That's it. A is equal to 4 because a squared is 16. The rest of it follows the form of the inverse sine function, so there you have it. Next one. We've got x over 1 plus x to the 4th. I will tell you now, this does not fit into any form immediately. You need to use a u-substitution, and this is going to be one of the weirdest u-substitutions you've seen. But I will tell you, you want to get the hang of this type of u-substitution. It comes out whenever I do these sorts of problems. If I were to let u equal 1 plus x to the 4th, let's just try it and see what happens. Then du equals 4x cubed dx. Now, this is a failed attempt. There is no way that I can make x cubed when all I have is an x. This is a failed u. I need to choose my u more carefully. And here's the idea. The only thing I have to make du with is this x. So I'm going to let u equal x squared. It seems completely off the wall, but there is a reason for this. Because du is 2x dx. This is one of the rules that will get me something with this du. So we'll play with this. We get du over 2 equals x dx. This is du over 2, but I still hadn't figured out what's going on in the rest of the problem. Here's the trick. I have an x to the 4th, right? Very, very frequently, when you see a problem that looks like this where you have to choose a strange u, very frequently you should calculate u squared. Notice that this is x squared squared, which is x to the 4th. So this is u squared. Unusual, but this works. So we get a 1/2 in front. All this is in the denominator, so it needs to stay in the denominator. I get 1 plus u squared. With that said, I get 1/2. This is the rule for the inverse tangent of u. A squared is just 1, so everything is just like inverse tangent of u. And then plug everything back in. 1/2 inverse tangent of x squared plus c. You might want to practice enough of these that you can spot whenever they're coming. Here's your next example. Same thing is going on here. A u-substitution that you might normally pick would be 9 minus e to the 2x. But that doesn't work here. The derivative would be 2e to the 2x. I don't have an e to the 2x. So I'm going to ask myself the question, what choice of u will give me an e to the x in my du? E to the x. That's the only thing that will have e to the x as its derivative. This will be our setup. Then this is my du. And then let's try u squared like I mentioned. U squared is e to the x squared, which is e to the 2x. This part is u squared. Good. So I have the integral of 1 over square root of 9 minus u squared du. We recognize that, or should, as the inverse sine function. This is the inverse sine of u over 3, because a squared is 9, that means a is 3. plus c. And back substituting, I get the inverse sine of e to the x over 3 plus c. For this one, I've got a pretty similar problem, but there's a 4x squared here. I'm going to think of this as 2x squared. And so with that in mind, I'm going to let u equal 2x. Then du equals 2 dx. So du over 2 equals dx. With that said, I've got du over 2. And this part is going to become, I think you can see it as u squared. So I get a 1/2 in front, integral of 1 over the square root of 1 minus u squared du. That's the inverse sine function. This is just inverse sine of u this time, plus c. So this is 1/2 inverse sine of 2x plus c. The next one's for you to try. If you want to go ahead and pause the video, I'll give you guys a little hint if you need it, and then I'll continue. If you need the hint, start out by looking at this as 4x squared. Now if you want to continue, feel free. And now I'll go ahead and do this video. U equals 4x, so du equals 4 dx, and so du over 4 equals dx. So here's my du over 4, and easily enough this is u squared. Get the integral 1 over 9 plus u squared. For the du over 4, put the 1/4 in front. Now you need the rule for the inverse tangent. That's what form this one is. A is 3 in this case, and the rule for inverse tangent is 1 over a inverse tangent of u over 3 plus c. So we end up with 1/12 here. Inverse tangent of 4x over 3 plus c. These last two are for you guys to try, but I think you might need a couple of little hints. Feel free to get started on these, and then I'll give you guys a hint, and then we'll work on them. Okay, here's your hint for the first one. If you need it, let u equal the natural log of x. Now for the second one, this one is not anywhere near as clear. What I'm thinking about is I see a 2 square root of x, and I'm thinking, hey, that's the derivative of the square root of x. So I'm going to let u equal the square root of x. Feel free to pause again and continue if you feel the desire to work on these first. And then I'll come back and help you guys in a moment. Let's finish these problems. So I get du equals 1 over x dx. And this is nice because I do have my du. The x in the denominator and the dx are du. And I have the natural log of x being my u. So I get the integral of 1 over the square root of 4 minus u squared du. That's the inverse sine form. I get u over a is 2 in this case. I get the inverse sine of natural log of x over 2 plus c. And then the next one. Told you guys this one was a little bit weird, but we'll work it out. Du is 1 over 2 square root of x dx. And that's exactly in the problem, so let's use it. The 2 square root of x and the dx are going to become du. And I still have an x floating around here, but remember I said look at u squared in this case. U squared equals the square root of x squared, which is x as far as we're concerned. This part is u squared. Putting all this together, we got a 3 in front. I'm going to bring it in front. This leaves a 1 as a placeholder, a 1 plus u squared, and a du. This is again inverse tangent of u plus c. So we get 3 inverse tangent of square root of x plus c. You might notice I did not use the inverse secant rules at all. Inverse secant and inverse cosecant are strange enough with the whole absolute values and everything that they're very, very rarely seen.